also carried out his collaborative research with the Laboratory of Production Management and Process in EPFL, Switzerland, and University of Hong Kong. Welcome, sir. I welcome you for the third session of today. Uh, Sir,
Thank you, Professor.
you,
Thank you.
yes, sir. You may start with the new session, sir. Thank you, sir.
Okay. First of all, good afternoon, all of you. Am I audible to all the audience?
Yes, sir. Yes, sir.
Good afternoon,
My
sir.
slide,
Yes, sir.
my slide is visible to everyone.
Yes, sir.
Okay. So my topic is on matteristic. How can we use to how can we use the matteristic algorithm to solve some multi-objective model? So first of all, I will show some glimpse how to use the matteristic. Actually, in this lecture, I will describe multi-objective genetic algorithm. Even I think in the previous lectures, I think Dr. Deepmala, she has already explained about the genetic algorithm. That one is a single objective. But if somebody want to use the matteristic for a multi-objective model, so how can we solve? How can we utilize? How can we use the matteristic or nature-inspired algorithm to solve the mathematical model? Now, basic concept. Actually, in the real world, we can say there will be a multi-objective scenario. Whenever you handle some scenario, let us assume manufacturing or transportation, it always happens there will be a multi-objective. Maybe you have to minimize the cost also, maximize the revenue also, and minimize the time of the production. So you can say in whenever we study some system or scenario, there may be multi-objective, maybe bi-objective, maybe more than two objective, tri-objective, even the more than three objective also. So how can we use the nature-inspired algorithm to solve? So whenever the objective will occur in the system, the objective will be conflicting. Okay, I'm giving you a simple surveys. Even leave the transportation survey. Let us think. If you are traveling, if you are traveling with the auto, okay, and due to the time constraint, if the passenger wants, he has to reach the railway station within a within a short time period, then the passenger always offer to the driver, I will pay some more amount of money, but I have to reach the station as early as possible. So just think, at that time the driver, he opt the smallest route. Okay, he opt the smallest route, but he is getting more money. So you can see that even at the time of transportation distance, he is traveling the minimum distance, but earning maximum amount. So you can easily understand the conflicting nature of the scenario. Just a So whenever this scenario occurs, conflicting scenario, so in that situation we have to find a solution that will satisfy both the objective. So we can say multi-objective optimization have a such conflicting objective function, and that will rise to set of optimal solution. So the solution will be, maybe the solution will more satisfy to the first objective and little bit satisfy to the second objective. So we have to decide which objective is the main priority, so we can give the weight also. Another option is we can find out the number of solutions that will satisfy both the objective function, both or all the objective function. So that solution we can show as a Pareto optimal solution. I will show what does it mean of Pareto optimal. Now this is a general concept of multi-objective. So in mathematically we can say that either the function will be minimized or maximized. So that will be the FIX, and maybe it depends. I's depend on the number of objective function. Maybe if we are handling number of objective function will be 2, then I will be 2. So I is the objective number of objective, and these are the constraints. Maybe the sum of the constraint will be equality constraint, and maybe the sum of the constraints are non-equality constraint. So whenever we handle with a mathematical model multi-objective, so it looks like this one. Obviously it is a generic form of model. In this you are seeing that there are only two constraints, but in actual scenario the constraint will be too much, maybe 64 or more than 64 constraint. I will show one case study. That will be the practical case study. You can easily understand how the mathematical model is easily utilized to formulate a realistic scenario. So in this you can see that x is a decision variable. Okay, x is a decision variable that will depend on the objective function. Now, why multi-objective? Most of the optimization problems naturally have a several objective. Okay, and that objective may be conflict. They always conflict with each other. In that case, we have to identify a solution, and the solution will be bounded by the constraint. That will be the constraint as per the scenario. So solution will lie within the constraints. Now, why evolutionary algorithms? The simple reason I can say that if you solve the model by exact method, and if you have a large data set, or data set is too much high, the number of complexity is too much high, in that case the exact solver, or we can say that in the market there are number of solvers available, just like a Simplex, Lingo, and so many solvers are available, so you can use that solver also. But if the data set and the number of variables and number of constraints will be high, in that case the nature inspired algorithm or the evolutionary algorithm will be helpful. So we can say that for particular suitable scenario we can use evolutionary algorithm to determine the solution. Now, classifying the techniques, we can classify in broad way. There are two type of techniques. Then that will be non-Pareto techniques and the Pareto techniques. Sorry. So we will see how can we handle the non-Pareto technique and Pareto techniques. So for the non-Pareto techniques, these are the techniques: aggregate approaching, vector evaluated genetic algorithm, the epsilon constraint method, target vector approach. I will show one case study how can we use the non-Pareto technique. Then classifying techniques, that is basically depend on the nature inspired. That will be the multi-objective GA, NSGA-II, and multi-objective PSO, Pareto evaluation strategy, and strength Pareto evaluation strategy. Now, actually, before going towards to the next slide, I would like to explain why we are using the optimization techniques, and what are the different type of optimization methods. Actually, in broad way, we can say that there are three ways to optimize the scenario. First one is the exact method. Okay, even in the 12th class, you have seen that by differentiating the equation, you can get the minimal or the maximal value of X or Y. So that one is also a exact method, a traditional exact method, and after that there will be a number of way, just like lingo, branch and bound method, number of ways, complex method. Even I think some of you have learned the operation research. So in that subject, the simplex method is also a one exact method. So first one is the exact method, and another one is the second type, we can say, that is metagistic, and third one is the heuristic. Now, the how can we justify which approach is more suitable for the scenario? So simply, whenever the complex scenario occurs, so we can say that we can use the nature inspired algorithm. But let us assume if you want to use the heuristic method, where we can use the heuristic. Even in the daily life, we are using the heuristic. I'm giving example of heuristic. Let us assume if you are traveling to your office, okay, from home to office, there will be a number of ways. Let us assume if you have a 5 way to reach your office. But how you are deciding that which way is the more suitable to you? So you will think that maybe the one way is more traffic but short distance. So your mind will think, let us assume this time is the office hours. So definitely there will be too much traffic. So this way is not suitable for me at this particular time. So you will opt another option. Okay, another option, another shortest route. So you will think that. So simply, maybe in some scenario you will think that maybe at the 3 o'clock or 4 o'clock that will be not office time. So you will think, we can use that particular way because that one is the shortest time and there is no traffic at that time. So we can use that way. So it means at the system analysis. Okay, and by using the heuristic, we can minimize or maximize the objective function. Now, non-Pareto techniques that do not incorporate directly the concept of Pareto optimum, and incapable of producing certain portion of the Pareto front, and efficient and easy to implement but appropriate to handle only a few objectives. So just like epsilon constraint method or some non-Pareto techniques, if we are using in that case, if the objective function will increase, so it will be very difficult to use that approach to determine the solution. Now, Pareto based techniques, that one is suggested by the Goldberg and Vega. Actually, it is suggested by the Goldberg and used by the Vega, our scientist, and they have used a non-dominated ranking method to select the population toward the Pareto front, and after that, on the basis of different techniques, identify the ranking procedure and to technique to maintain the diversity in the population. Now, the concept of the Pareto optimal. So, in the absence of weight, let us assume initially I told you if you have a multiple objective, and as per the scenario, you can determine. Let us assume objective one is more important or priority in comparison to the other objectives. So, you can assign the weight, highest weight, with respect to objective 2 or objective 3. But in that case, it is very difficult to find an optimal solution that will satisfy both the objective function equally. Sorry. And classical optimization method, that one with a multi-criteria decision making, we can use by making a questionnaire and circulate to the expertise to determine the solution. We can also use the MCDM technique. Now, concept of Pareto you can easily understand. Let us assume we have a two objective function, means x1 and x2, and this is a decision space. Okay, this is a decision space, and these are the solution. Okay, means these are the Pareto fronts, and these red dot are the Pareto front approximation. So actually, Pareto front is a curve like I will show in the next slide. So after getting the solution, means previously it will search in the solution space and identify the solution, and after that, after the evaluation on the basis of fitness function, the solution will determine. Desirable multi-objective evaluation algorithm features convergence to the Pareto optimal frontier. You can see that this one is a Pareto optimal frontier. So, on the basis of crowding distance, we have to identify the number of solution at the Pareto front. So, and after that, on the basis of the ranking system, we have to rank the Pareto front, means first front, second front, the third front, and solution the first nominated front, solution in the first non-dominated front have the highest fitness. Even we can say that if we are considering a function of minimization, means it means this values is a better than the second and the third front. So we can say that the F1 is the first front, and that will be the highest best possible solution for the F1 and the F2 function. Now, this one is algorithm. That one is a non-shorting genetic algorithm, and the features are fast, non-dominated shorting. So, first of all, for each solution, we have to generate a population, random population, and NP. In mathematically, I am saying that number of solutions that dominate the P, and SP is a set of solution that P dominates. So then after place all the P with NP is equal to 0, because initially we have to consider the 0 in set F1 because it is an initialization process, and after that each P that will be belongs to F1 visit each Q belong to SP. So it repeat up to the determined solution, or up to the optimal solution. This one, yeah. Now if you are solving a problem and you get the Pareto optimal solution like this one, so on the basis of crowding distance we have to identify which which solution is giving the better solution. So we have to use this formula. So this one is a crowding distance formula, and by using this function we can determine the number of population of solution that is giving the best solution. Now given two solutions I and j, and solution is I is preferred to the solution j, so we have to identify, means we have a different Pareto funds, so we have to compare, and on the basis of that we have to get the best fitness value, which solution, which pair, which crowded population is giving the best solution, we have to select that. Now these are the some steps. So initially we have to go for the initialize of the population. Then after, on the basis of after the initialization, we have to go for the fast non-dominated sorting, and then after calculate the crowding distance, and after the crowding distance calculation we have to use for the tournament selection, and after that we have to go for a crossover. These are the well defined operators of GA. Actually the crossover is basically used for the determine the local optimum solution. Sorry. So crossover after the getting the local optimal solution, and then after it goes for the mutation operators, and after the mutation it will give the global optimal solution. Actually the crossover and the mutation is mainly responsible for the exploration and exploitation of the solution. Then after combine the parent population with the offspring population, and after that we have to replace the worst solution among the means, we are combining the parent population and the offspring population. Now we have a P1 and the P2, and after that we have to rank the population, we have to rank the font, and the worst population we have to remove that, we have to remove from the population. So better you can, I will explain by example, that will be more easy. Yeah. Now example consists of total 18 activity, and each activity has an alternative to complete the project, namely time, cost, and quality. You can see that we have a three objective in this problem, that will be time, cost, and the quality. And each alternative influences the three objective function: project time, cost, and the quality. You can understand that if the project time will be reduced, the cost will also reduce, and if the project time will increase, the cost will also increase. Even we can say that if we relate with the cost and the quality, if we reduce the cost as below, okay, means the cost will be minimized to inclined toward the negative side, or just like as minimum as possible. In that case, the quality will also degrade. So we can say that all three objective functions are they influenced each other, and all we can say they are conflicting with each other. So we have to find out a solution that will satisfy all the three objective function. So in this example, there is an average 3.12 option to complete each activity, and this create nearly about million 3.12 for 18 combination for scheduling the entire project. So this is a network diagram. You can see that there will be a number of activities and number of options to finalize the task number 18. So we have to identify which schedule we have to follow, which activity we have to complete first. So project network has 11 path to complete the project, and project duration varies with alternative. Definitely, if we choose the different alternative, in that case the duration will change. So we have to identify the critical path also. Now objective of this problem is to identify a best alternative that will balance the three fitness function, means project time, cost, and the quality. So we have to minimize the project duration and minimize the project cost, but we have to maximize the project quality. So our in this example we have a three objective function. Now you can see that this is a data set. We have a 18 activities, okay, and for the bid option we have just like in the first activity we have a 5 option, and for the first option it is taking 14 number of days and cost is $2,400, and the quality is 100%. Definitely if we have a too much high cost budget, definitely I will choose the first option. But as per the cost constraint, we have to identify a solution that will satisfy the whole project. So we have to identify a best option with respect to activity. Similarly for the second also, similarly for the different activities. Now encoding of the chromosomes, you can see that X represent the gene, and these blocks are representing the activities. We have a 18 number of activities. You can see that, and index n represent the alternate of activity. Means this x1 n means for the one we have a 5 number of bidding options. So for particular block we can say that x11, x12, x13, x14 and x15. Similarly for this one also you can say that in the second option again we have a 5 option. So we can say that x21, x22 and x23 up to x25. But in the third option you can see that we have a single option. So in that case the chromosome will be x x31. So in that way the chromosome will form. Now first of all we have to initialize the population, and after that that random population we have to calculate the fitness function. That will be the child population, and after that we have to go for a fast non-dominating sorting and calculate the crowding source, and after that create the child population using the genetic operator. We have to use the selection process, crossover and the mutation, and again calculate the fitness function. But if in this case at the time of child population, if it is yes, then combine the parent population of size n and with the child population of n. It means in that case we have a 2n population, and after that after the combining of child and the parent chromosome, we have to go again for the fast non-dominated sorting, and then after create a new population, and then after in the last we have to calculate the fitness function and check whether the fitness function is feasible with respect to the constraint or not. If it is feasible, then we can say that that will be the stopping criteria. So in the first case, we have to create an initial population of the solution. So first of all, we have to go for a random generation of initial population. Then after, as per the local search and the feasibility, we have to check, because maybe if there is if the random population is not feasible with respect to constraint, in that case again you have to go for a random generation of population, and again check for the local search and the feasibility of the solution. If it is feasible, then go for the next step. Now for this problem I have considered a population size is 300. You can see that I have considered a 300 number of population, and this one is activity alternative. So you can see that we have 18 number of activities, and this one is selected by the randomly selected by the programming. Just like in the first activity, the fourth number of bidding is giving the best possible solution, and in the second alternate in the second activity, the fifth number of solution is giving the best solution. So in that case, in the same way, and after that for the each population, means for the first population what will be the time, we can calculate by the objective function, and similarly cost we can calculate, and the quality. Now we can say that we have a 300 solution. Now from the 300 number of solution we can say that we can identify which number of which population is giving the best solution. Now now for the step 2, that will be the non dominated sorting. So first of all, identify the best non-dominated set. Means let us assume if we have these sets, then after that we have to rank the set of the population. Means we have to rank 1, rank 2 up to the rank. We have to identify. Now, on the basis of the crowding distance, we have to identify the Pareto optimal front, and we can say that just like from the figure, you can identify the solution B is more crowded than the A. But as per the formula, we have to see which crowded is more suitable for the solution. Then after the tournament selection, now perform the tournament selection using the crowding comparison. On the basis of the crowding comparison, we have to select, we have to rank. Then after go for the crossover, just like for the parent 1 and the parent 2. Then after the crossover, the offspring 1 and offspring 2 will be generate. And after that, we have to go for a mutation operation. It depends on the mutation probability. And after the mutation, this will be just a pictorial representation how the mutation will occur. Actually, the mutation probability depends upon the number of chromosomes. So in this scenario, I have considered that in this scenario we have a 18 number of activities, so we can say that we can consider the mutation probability as a 1 by 80. Then after elitism occur, elitism is a process in which we combine the population. We can say that the n number of the parent population, n number of child population, and total that will be the 2n. And elitism ensures that the fitness of the best population doesn't deteriorate in advances. And it helps to prevent the loss of good solution, because in the elitism we identify the worst solution. And after that, that set of the worst solution we have to remove that. So we can say that worst solution we have to remove. From the pictorial representation, you can see that let us assume pt is a parent and qt is a child, and after the combination this will be the 2n population. And we have dominated the ranking f1, f2 and f3. Now you can see that the f3 means initially the f1 and f2 is okay, and f3 these f3 sorry below these two fronts are not getting, means these are the worst solutions, so we can reject these solution. And after that we can identify, because we have to select the n number of population. So among these reason we can say that f1 and f2 can be selected, and from the f3 we have to select these portion. So in that case this will be the population for the next generation. So on the basis of this one, we have to calculate the next fitness function. So combine the population with RT is sorted according to the non-domination, and solution belonging to the non-dominated set F1 is considered as the best solution in the combined population. And let us assume if the size of F1 is smaller than the population size n, then choose all members of F1 for new population, that will be the PT plus 1. And in the remaining member of the population are chosen from subsequent front in order of their ranking. So we can say in the generalized form, the count of the solution from F1 to F2 would be larger than the population of size n. And by using the crowding operator, we have to choose the last front, because we have to remove the worst solution. And these are the parameters that I have considered in this problem. That will be the population size is 300, generation I have considered 1000, and probability is 0.8, and mutation is 0.1. And after that, by running the program, I got this solution, because It's a three-dimensional objective function. So this will be the project quality, project cost, and the project time. So I got a surface that is giving the, we can say that one is this surface is giving the solution that satisfy all these three objective function. And this is a, we can say this is the final optimal solution. Now the question arises, definitely the question will arise, how can I say that all the five solutions are the solution of the objective function? So whenever we handle with the materialistic, either single objective, multi objective, so whenever we handle with the nature inspired or materialistic, it always gives the optimal solution, near optimal solution. Okay, near optimal solution. So means that will be not the exact solution. And whenever we handle with the multi objective, so in that case the number of solution will occur, and that solution will also a near optimal solution. On the basis of near optimal solution, we can plan the system, we can plan the scenario. So this is a solution. Now I would like to share one practical scenario with you. Is it visible to all of you? B2B scenario. Is it visible?
Yes, sir, it's visible.
Okay. I think this one is a realistic scenario of a e-commerce, and I have considered this scenario of a one company located in a Hong Kong. So I got a data set from that company, and actually I got a one consultancy project. So they want a decision support model, just like I'm giving again a realistic example. That Amazon or Flipkart, most of the consumers, and initially the Amazon are giving a two option. That means if the consumer want instant very short time delivery, in that case the consumer have to pay amount of more amount of money. So if the customer will pay more amount of money, in that case the project will deliver to the customers within the short duration. So the company want, how can we decide how can we decide a solution that will satisfy the time and cost both, because if we are reducing the time, the cost is increasing. So the solution means the company wants a solution that will satisfy both the objectives, that will be the time and the cost both. So uh, to show, yeah, this one is the exact scenario. Let us assume these are the zones: zone 1, zone 2, zone 3. There will be a number of zones, and under the zones there will be a number of suppliers. Okay, and similarly we have a regional zone, means customer. Let us assume some of the customers are from Jabalpur, and some of the customers are from uh, Banaras. So they make a cluster. Okay, and they, after the defining of cluster, they just define the zone 1, zone 2, and number of zones. Okay, so you can imagine how many number of data sets they are handling, and they have a decision support system, online decision support system, just like you are using in a internet, Amazon and the Flipkart. So this one is our decision support system. And how does it work? You can easily understand by this figure. So whenever the customer, whenever the initially the suppliers share the information to the decision support system. Let us assume each and every suppliers have a different variety of products, P1, P2, P3, and Pn. Okay, number of products are available at the suppliers. So they share the information to the decision support system. Decision support system means share the details, means the cost of the product and the variety of the product. They share the information, and after that the customer, whenever the customer see the product price on the decision support system or the online e-commerce platform, after that whenever the customer want to buy a product, they just purchase the product through the decision support system. Is there will be some information flow between the customer and the decision support system. Similarly, for between the suppliers to the decision support system. Now another entity is also important, that one is the logistics service provider. Just like in India, they are using own logistics service provider, just like a Flipkart and Amazon. But initially, they have a third-party logistics system. So in Hong Kong, they have a third-party logistics system. So sometimes DHL or different logistics service provider, they just share the information to the decision support system, just like how many number of vehicles and the type of vehicles are present to transport the good to the to the zone, to the customer. So due to the proper synchronization of information, we can say that there will be a minimum delay during the delivery of product and minimization of the transportation cost. Now the problem occurs whenever the customer will buy a product and pay more amount of money to deliver the product as soon as possible. So in that case, the information is very important. And after the proper synchronization of information, the physical flow of product will flow from supplier to the different zones. Now again, the question will arise: how the supplier we can supply the product to the different customers? In that case, the region has our own distribution center or a small warehouse where they collect the product, and after that they sort out with respect to the different area of zone, and after that they supply the product, and that term is known as last mile delivery system. Even you receive the product by the courier guy, which who came to your house by a bike or some small tempo. That will be the last mile delivery system. So that last mile delivery system I didn't consider in this problem. Now on the basis of time horizon, we have to decide on the basis of GPS system or the pin code how much time it will occur to deliver the product from supplier to the customer zone. On the basis of that, e-commerce platform or decision support system will give the time the product will deliver on that particular date to the customer. But if the product will deliver the product beyond that promising time, in that case the company have to pay, or we can say the logistics service LSP, the logistics service provider have to pay a penalty cost to the company. So and after that the company gives the reward point to the customer, because the customer is facing problem due to the delivery time. So it happens in the Hong Kong city, Hong Kong country. So on the basis of scenario, I have formulated a model and a mathematical terms. You can say that suppliers, sub retailers, product, order batches, and these are the input parameters that is known to us: total availability of product, डिमांड कितना है, फिक्स्ड कॉस्ट, एवरेज डिस्टेंस. So actually in this model I have considered three type of vehicles, that will be the small, medium and the large size of vehicle. So these are the parameters, you can see that. And after that, these are the some decision variables. On the basis of that decision variables, we have to calculate the objective function, means the quantity of order batch k moving from node I to j, how much number of products will move, and how much number of large size vehicles required to shipment or for shipment of the batch k. So these are the some decision variables. And expected delivery कितनी होनी चाहिए, just like on the basis of the distance, the e-commerce platform calculate the expected delivery time. And early pickup time means at what time the logistics service provider can pick the product or make the batch size from the supplier. So early pickup time will calculate by the decision support system. Then late pickup time, early delivery time, maybe in some cases, uh, maybe in some cases the product will deliver before the promising time. So in that case, again there will be a issue to the customer, because on the basis of the promising time, the customer has to manage. Means the customer is managing the time. Means let us assume the decision support system, if the product is showing that the product will deliver on the 15th of the December. So in that case, the customer will customer will await the product on 15th. Maybe in some cases of the customer will arrive at 13th of the December. In that case, the customer have to take some we can say some have to take some time to receive the product. So again in that case, the company have to pay penalty cost. Means the company have to provide the good within the same promising time, that one is calculated by the decision support system. And some more decision variable, and these are the some binary decision variables. Means if the value of this decision variable will be 1, then if batch k shift from node I to j is 1, otherwise it will be 0. So similarly these are the some decision variable. uh, Now you can see that there are number of decision variables. Okay. Now on the basis of these decision variables, I have formulated how to calculate the transportation cost. Now there is two possibilities. Now you can understand the practical scenario. Let us assume we are a we are a owner of logistics service provider company. Okay, and let us assume definitely you will try to full truck load, because if the truck will be less load, in that case just like I'm a company owner of e-commerce, in that case I have to pay the same amount of money and the product is less in comparison to the vehicle capacity. So there will be two scenario: either the process will be either the product will move with a full truck capacity, another one is less than truck load capacity. It means in that case the truck will be vacant, maybe slight vacant, maybe half vacant, it depends on the scenario. So what will the transportation cost in both the scenario? Now after that the penalty cost may be due to the late delivery or the early delivery or late pickup or the early pickup, there will be some penalty cost. And after that this will be the carbon emission taxation cost. Why I am calculating the carbon emission taxation cost? Because now in each and every country the government are focusing to reduce the carbon emission. So they have imposed some policy, environmental policy, to reduce the carbon emission from the logistics service provider or different associated companies. So I have calculated the carbon emission cost on the basis of the on the basis of the distance and the time. So the logic behind the carbon emission taxation cost, you can understand. Let us assume if the vehicle will travel large distance, or we can say that the vehicle will take too much time, will take too much large time to deliver the product. Definitely the carbon emission will take too much high. So trying to reduce the carbon emission taxation cost by using this formula, and after that, this will be the one cost, means this will be the transportation cost. We have to choose the minimum value of P1, P2, P3, P4, and because we have a four cases. P1 is if you are using a small size truck, medium size truck, and the large size truck, and the P4 is a full truck load. So we have a four cases, so we have to choose the minimum cost, because we have to minimize the transportation cost. This will be the penalty cost we have to minimize, and the carbon emission cost. now now there will be a two cases: priority based delivery and the normal delivery. If the customer is paying more money, in that case the company has to deliver the product as a priority basis. In that case, the processing and the handling cost will be different. So in that case the cost will be this one. Maybe if the customer is paying the just like a normalized or regular amount of delivery, then in that case the processing and handling cost will be different. So we have to minimize the total cost, and after that, on the basis of we can say the total time, because both are conflicting. Because if the customer is paying more amount of money, then in that case the time will be reduced. So we can say both are conflicting with each other, so we have to identify a solution that will satisfy both the objectives. So I have developed some heuristic. Now the question will arise: how I can develop a heuristic? Simply, we can say that on the basis of the it's a rule-based greedy heuristic method. So I have analyzed the scenario, means on the basis of capacity of vehicle, we can decide which type of the vehicle. Because let us assume I am giving an example. I think everybody knows Hindi, so I'm giving example in Hindi. It will be more easy. आप ये समझिए, आपके पास तीन ऑप्शन है. ओके, थ्री टाइप ऑफ व्हीकल्स यू हैव, T1, T2 एंड T3. ओके, एंड T1 की कैपेसिटी लेट अस अज्यूम, T1 स्मॉल है, तो T1 लेट अस अज्यूम 10 यूनिट ऑफ कैपेसिटी है, और मीडियम की 20 है, और हायर की 30 है. Okay, now you have to deliver a product by using any of three vehicle. Okay, to the any three of the vehicle to transport the good from source point or supplier point to the destination point. Okay, now if you are using the smaller vehicle, okay, sorry, the demand capacity is important. If the demand capacity is matching with the smaller vehicle, means let us assume the demand capacity is 9 unit. So which capacity vehicle we have to choose? We have a three option. तो ऑब्वियसली हमारे पास छोटा 10 है, 20 है, 30 है. यदि हम 30 चूज करेंगे तो डेफिनेटली बड़े वाले ट्रक यूज करेंगे. सो इट मीन्स वी हैव टू पे मोर अमाउंट ऑफ मनी, और ज़्यादा से ज़्यादा स्पेस वैकेंट रहेगा ट्रक में. Similarly, if we are using the medium size vehicle, again the maximum vacant size will occur during the transportation. Now if you are using the third type, smaller size of vehicle, that will be the 10 unit, and the demand capacity is 9. If you are putting the 9 in the 10 unit, so it means obviously in compared to the second, the third, the smallest truck is more economical. So on the basis of these type of scenario, I have developed a heuristic. Okay, and how many number of trucks can be used to transport. So on the basis of heuristic I have developed. Now these are the some constraint because some scenario have some boundation, just like available capacity constraint कितना होना चाहिए, demand constraint match करना चाहिए. So these are the some constraint. Just like a constraint restrict the order should not deliver at the same pickup point. So these are the constraints, and these constraints identify the number of vehicles required for the delivery of order. Now after that I have used the epsilon constraint method. Actually I have used the two method, that will be the epsilon and the weighted sum method. We have a two objective function f1x and f2x. So whenever we use the epsilon constraint method, in that case the second objective function we have to convert into a constraint by this way, f2x, that will be less than greater than equal to epsilon 2. Remaining constraint will be remain same, and after that these are the parameters I have used, and these are the results. Okay, so after that you can see that I've used the this one is epsilon constraint method, this will be the weighted sum method. Weighted sum method I have just randomly assigned the weight to the objective, and identify the, just like I identify hit and trial method, which weight will be more suitable to the which objective, and after that I got this solution. So we can say that by using this decision support system we can analyze that whenever we use the priority based delivery system, that will be taking too much cost, but we are reducing the time also. So this will be the one case study, realistic case study. So my topic is over. So from the audience, if you have any question, please let me know.
Unmute करतो.
Thank you very, thank you very much, Dr. Saurav Pratap sir. It was indeed a very informative session. I hope all the audience might have get benefited it, to the most level. And even I understood this topic very well. It was very interesting when you told us about logistics and delivery system. I, on the behalf of whole organizing committee, once again thanks you, and thank you, sir.
Thanks.
Yes, sir. There is a little announcement regarding tomorrow's session to all the participants. Tomorrow we will have Colonel B. Venkat. He is Director and Faculty Development Program of AICT, and he will be the chief guest for our valedictory function. This valedictory function will start from 1:30 p.m. tomorrow. And tomorrow there will be two sessions. The first session will be as it is from 10 a.m. to 11:30, and the second session will be from 11:40 to 1:15 p.m. Thank you all the participants. I hope you will get maximum benefit from these ongoing programs, and thank you all.
Thank you.